look at, in terms of volumetrics, calculating volumes of, doing volume analysis. That's what you might have done your survey. Looking at this now, it's easier to put your models in 3D. When your models are in 3D, they are easier dealt with. Now, we'll look at, I will show you what we did here. Let's display a grid of the 3D we are talking about. We're going to display a voxel grid of an IP data. Let's use IP for the entire line. That's how you can see KP1 to KP4. That are the 4 lines we took. We'll combine them into a 3D format. Okay, I think we'll have it already here before. Let me display it again. Okay. Now this is what we'll have. This is what we'll have at the 3D. Now, if you look at this, we have 4 lines. In this model, what we try to do is, if you look at this, here to here is your horizontal line, right? This is the east and this is the west. Because you remember we started from 0 to 230, 240, 237, because our line spacing is 4,4, right? Now, this is a 3D format. This is your vertical. Why this is your horizontal? This is your y-axis. You get it? Now, what we did here is this. If you look at here, there is space here. You can see this, you can rotate this 360 and all that. There's a space here. Now, we can reshape this into actually whatever we want. But if you look at this, this shows the first, it modeled this as a block. So we placed it, we have interprofile spacing of 50 meters. Now, the interprofile spacing of 50 meters, from here to here is one profile. Do you understand? Another profile starts from 50. Do you understand? Another profile starts from 50. That means this. Then this is the last profile. The other 2 profiles are combined as one block. Now what we did here. Now, this other profile, which is profile 3, is at 100. You understand? So if you look at the entire length here, we're talking about 150 meters. Because this is -3. This is 153. 153 plus -3 will give you 150. Did you get it now? So the same thing here. This is 240. -3 here and 234. You get it? Now, looking at this now, you might not really make a full meaning of this, but you can actually turn it up like this. See the bottom, see the sides, see, this is your east, this is your west. Definitely this is your north. So now this represents changeability. We have changeability, we have conductivity, we have resistivity, and we have the SP, all in 3D. But we are trying to look at what the changeability looks like, the induced polarization. This data was actually gathered using Geomative GD10. Now, let's look at this and see if it makes sense. Now, if you look at this data, this is the entire data. But we can separate this data in terms of depth, in terms of length, in terms of width, in terms of content of changeability. Now, for example, if you want to see, you are interested in seeing from 0, maybe you want to see surface anomalies. you are interested in saying, is there any anomaly within 5 meters? Do you understand? And we are talking about depth. So this is, it's a within 5 meters, right? Anomalies within 5 meters. You want to see anomalies within 5 meters. See? Every other thing goes off. You see? This is anomalies within 5 meters. You want to see just within 5 meters. So you can look at from the top here. You are seeing that this place is increasing gradually at this particular point, and that is about within the third line. Then you can also increase, you can say you want to see anomalies within 10 meters. Are you seeing it? This minus 10, minus 11. Are you seeing that these anomalies is getting stronger here? Are you seeing it? It's getting stronger here. Then you can also, and you can see this particular line is a bit different from all this, the entire region. Now you can say you want to see, you can increase the depth. You can say you want to see 15 meters. Are you seeing it becoming clearer? This is within 15 meters. That is depth-wise. Now, you can go down to, you can increase it down to 20, between 20 and 24. This is what you will see. You can see the bottom of it. It's clearly showing here. Now, now the essence of this is you can easily have a clearer presentation when you are talking to someone who do not actually understand these things in 2D. You understand? You can easily see the whole block of where you've actually worked on. Now, let me tell you another thing that is very interesting with voxel breeding. If, let's say we've shown everything and all that, now we want to look at our changeabilities. At this, we have our range of changeabilities start from 0 point something to about 237 milliseconds. Now we want to see where do we want to exclude, exclude all changeabilities that are less than, say, 30, for example. See, the more you decrease, these are changeabilities that are less than 30. See where they are appearing. We want to see, as we're increasing, we'll be seeing the blocks. Are you seeing the blocks? We can see the blocks that have the highest changeability, where they are concentrated. Now we can keep decreasing. You understand? We are trying to eliminate. Now 43, you see, 43, 50. Are you seeing it? You see, most of the concentration, are you seeing two major concentration? There are two blocks here on this line. There is here, but this is deeper. This is bit at the surface. You can see. And this actually is a clear, can you see that there's a clear kind of fault here? There's a clear demarcation here. Which when you go to 2D dimension, you will clearly see the fault. You get it now? Now you can see, if we keep eliminating, now we're at 100. Are you seeing that everything is just constituted within the line 3? You get what I'm saying? This is there at first line, but it's at deeper source. You get it? And at a deeper source, and understanding the resolution of electrical method, the more you go down, the noisier it becomes. So you are likely to get better result at surface compared to deeper source. So if you look at this, you can see this block here, and you can see this block here. Okay, that is actually what you have. Now you can look at the anomaly, but you don't know the depth. Is that? You don't know the depth this is coming from, but you can eliminate depth here and see where they are coming from. Your depth here, you want to eliminate depth. You've eliminated 10 meter. It doesn't appear within 10 meter. It doesn't appear within 12 meter. You see, that means the anomaly started at about 15 meter. You see, so it means that the anomaly here started about 15 meters. You have much more here and here at about 15 meters. Then if you increase this to 50, your chargeability, 50 milliseconds, you see strong mighty blocks here. So you don't have any option than to actually punch. This is the major plates you are targeting. And what is the profile length? Let's see where it falls in terms of your length. You can eliminate, you see, eliminate. You want to target this block, you start eliminating. This is at 55 meter length, 55 meter, you see, that is at 115. So at 120 at the middle here, are you seeing it? So are you seeing that this is a continuation, a kind of, on this line, it disappeared here, but you can see that at 103, length down to, okay, let's see where that is coming from. So from 103 to 191 length, possibly.
Okay, you're actually saying that this block and the other block, they are the same thing, just that the fault occurred.
Yes, no. What?
Break the two blocks.
Now remember, yes. If you look at this, now when we show up everything here, for example, you see, if we show everything here, this is our 3D of the entire thing. You see it? Now, you might not really appreciate it now until possibly we show, maybe let's see a section grid. This section grid for, let's look at a section grid for line 3, the IP. Have you seen it? Have you seen a very clear? Have you seen it? You see, if you bring out, this is line 3. Have you seen? Now, if you look at this, you see the profile length. This is at 130 meter from 0. And you can see that this is narrow and it's dipping west. likely dipping because this is your east. The profile start from here to there. You get it? You can see it's actually dipping, dipping west here. And you can see a very clear demarcation that there is with index. It showed up there. You might not have to, but if you look at it, you can see a very clear demarcation here that something, there's a fracture here. You get it now? Now, if you want to look at more information, and at this particular place, this depth, you can see the top of the anomaly. Look at the Z. It's minus 8. The center is about minus 18.4. Are you saying it? You can see the IP chargeability here, 35. You can see the conductivity. You can see the resistivity. And you can see the SP. Now, if you actually want to appreciate this line 4 as what we've done before, you can look at, line 3. Line 3, this is section, okay, this is KP4, right? That's KP4. You can see KP4 brought out a very clear, this is KP4, that's line 4. It brought out a very clear fracture here. Okay, if we want to show the line 3, let's say line 3. Wow, are you seeing it? Are you seeing line 3? Section of line 3, are you seeing it? Have you seen it? You see? Have you seen? You see? It's pointing there. You see what's going on? That is it. That is the point. In 3D. You get it? That is it. You see? That is it. It's pointing to this anomaly here. Why this? This is the way it looks like. Why this is pointing this? Have you seen it? You see? It was very clear when we do the voxel analysis. You see? That is actually line 3. That is where it's coming out from. And you can see that even in line 3, there is still a very clear fracture here. Why was there no continuation here? Now, if you want to look at the resistivity of the same section, you can look at the resistivity of line 3. See resistivity of line 3. Are you seeing? Have you seen the same thing? You see? This continues this. And the suffix is because of some of the latritic materials at the surface, oxidations and all that. Definitely you see the high resistivity here. And that means the top actually contains ion which can conduct. You can look at the conductivity of the same place. Oh, you see the conductivity. Have you seen it? See the conductivity here. So you can look at it, see the IP here, look at the conductivity, and look at the conductivity and look at the resistivity. Are you seeing it? Yeah. Then you can also try to look at the SP. let's see. Let's see the SP grid. This is the SP. Okay, you see the SP anomaly here correspond with IP anomaly here. Does that make sense? You see why line 3 looks very good. The SP here, because most of the SP anomalies, the sulfide mineralization actually shows high negative SP anomalies. The SP anomalies, high negative SP anomalies are depicted by these colors. Now you can see it here. Now that is low resistivity, possibly because of the shale hosting formation. It's expected that the shale can show some low resistivity and high conductivity with high changeability, and because of the sulfide mineralizations, and also correspond to at a reasonable conductivity here. So you can see that the parameters match for this, which might not match in other lines. And that's why, if we want to look at this, which has actually shown us a very good correlation, we can eliminate some data and we can see this is what we are seeing here in 3D. Look at it. You see, this is this anomaly, this block. This is the block here. You see, when you click, you see the point here. See this anomaly? Have you seen it? Have you seen it? So here, it merges this and this, merges them and block here, a kind of, but this is actually what we are targeting. You got it here. But when you're looking at this in the block, it's as if they are merged. There's an opening here, but they merge somewhere down here. So it's as if you can see this can be a different passage of veins. Do you understand? This, you can see it here. So that is for that, and this is for this. Is that clear? I think so. That is the advantage of actually processing your IP data in a well represented format, especially using Voxel analysis. So, can I get your questions?